My name is Mike Juniper. This is Alex Harris. We're with the Washington, D.C. R&D Center. We're the team that builds ArcGIS Open Data. If you want to follow along, my presentation is at that URL there. And then if you care, all of my presentations from the last few years are in that repository, that bottom link. ArcGIS Open Data. Who's using ArcGIS Open Data? Anybody? Couple? Okay. For the benefit of those who aren't, at a high level, ArcGIS Open Data allows you to take your authoritative data that you may already have in ArcGIS Online and make it searchable, explorable, and available to the public. And basically the way it works, again, at a high level is you take your open data and you share it. Well, first you enable open data on your org. That's just checking a checkbox. And then you share your open data into one or more open data groups. And then finally, using our admin site layout editor, you create and customize one or more open data sites and make them public, and you're rocking. We have one thing that's a little peculiar and maybe a bit of a stumbling block in open data that's different from the rest of the platform, which is the notion of a data set. A data set basically corresponds to a single layer in a feature service. So you've got a feature service with 3 layers, you share that into an open data group, and you're going to have 3 data sets, one for each of those layers. These are some examples of some of our customer sites. These first few were built with our previous iteration of our software, but they still look pretty good. We've recently vastly improved the site editing experience, and these more recent ones, these last few here, are used with the more recent version of the software, and I think they look really nice. That one, of course, is that's ArcGIS, opendata.arcgis.com. That's Esri's open data site, and basically anything that anybody in ArcGIS Online shares to an open data group will show up on that site. But what if, what if you want to use open data, but our site layout editing experience is insufficient for your needs, or maybe you have data in some other system, not in ArcGIS Online, that you want to surface in ArcGIS Open Data, or maybe you've got a website that you really like and you just want to add an open data search widget to that page, something along those lines. Those sort of, I think, fall under the broad umbrella of interoperability, different systems working together, and that's what we're going to talk about. Alex is going to start out by talking about something called Coop. Then he's going to talk about DCAT. And he's going to wrap up by talking about the Open Data API. And then I'm going to talk a bit about an Open Data Search web component that we've open sourced, and wrap up by talking about how you might, if you were so inclined, build your own web application or other desktop application, possibly, against the Open Data API. And I'll show you a couple of web apps, sample web apps that I've built and we've open sourced. So, Alex Harris.
Hello, can everybody hear me okay? In the back, thanks. So yeah, my name's Alex Harris. I'm an engineer with the Open Data team based out of DC. And I'm going to give you sort of a quick overview of Coop. There were several talks about Coop. I think they're all done, unfortunately, but I will also direct you to some slides and some other resources where you can learn more about it, sort of beyond what I'm going to tell you right now. So the highest level concept of Coop is that it connects other APIs to ArcGIS. So if you want to pull in data from Yelp or Craigslist or sort of any other third-party source that doesn't really speak the feature service or geoservice language, Coop is the way to translate between the data store and the ArcGIS ecosystem. It's open source. We have a repository, Coop. We also have a GitHub org, Coop.js, so anybody can take a look at what we're doing there. It's written in Node.js. It's basically an Express app with sort of a special, basically middleware for doing the translation. And again, as I described, it converts third-party APIs into feature services. We use it also on our team. It's sort of like a custom Coop for generating our downloads. So this is how we generate KML, CSV, shapefiles. We also provide GeoJSON links and things like that using Coop. So this is a pretty old diagram. We use it pretty often. It's sort of Coop in a picture. So you have this sort of rainbow of all these different data sources, ArcGIS Online, Socrata. We can even pull in data from GitHub, pulls it into Coop, and then Coop basically speaks two formats, GeoJSON and feature services. So you could use Coop to generate GeoJSON and put it in a leaflet map, or you can generate feature services and then put them in desktop apps or ArcGIS Online web apps. So Coop providers are sort of, if you're looking to get involved, this is the part where data is translated from a third party into something that Coop understands. So it's basically responsible for translating any third-party API into the GeoJSON format. Because once you have it in the GeoJSON format, Coop can handle the rest. It knows how to translate any GeoJSON into something that looks like a GeoService, a feature service. So here's sort of a example of using a provider. So Socrata is a different open data provider, and you might have a open data set here about schools. We basically go to their API, so this is where that resource lives. We pull it in using Coop, so we have this sort of Coop instance that we like to do demos and stuff from. And you see the URL there, /Socrata, so that's the Socrata provider, /Seattle, so we are pulling in the Seattle Socrata, from the Seattle Socrata portal. You have that ID, and then the URL even kind of looks like a feature service, so we stick at the end /feature server /0. And what that enables us to do is to say, well, cool, let's turn it into an ArcGIS Online item. So we just create a new item, plop that link in, and now we've got something in ArcGIS Online. And if you want to take the final step and bring it into ArcGIS Open Data, you just, as Mike described, you put it in an Open Data group, and we will bring it into ArcGIS Open Data, and that data set is now, you can visit it at that URL. So that's sort of the journey from bringing in data from a third party all the way to open data in this case. And so for Coop providers, for Coop 3.0 or greater, which was just released, I think, last week, you can go to the docs. They're pretty clear, and we'll give you some examples and we'll link to other resources. But the basic nutshell is that you implement a single function in JavaScript. And that function, basically, all it does is it's responsible for fetching data from an API and translating it into GeoJSON. And then you pass it to a callback, and Coop will handle the rest from there. And these are the resources I mentioned earlier. So if you want to take a picture of the slide, I can pause for a minute. But Daniel Fenton, who is the main maintainer of Coop, who works on our team as well, he did a presentation, I think, earlier today that went more in depth into this exact topic of bringing in third-party services into ArcGIS. So it looks like a few people wanted to take a picture. So I can kind of give a quick version of the demo that Daniel did earlier. So the demo uses open data from DC's open data site, which was made using the old version of our open data software. We are also using Coop providers for Zillow, Craigslist, and Yelp. So these are third-party APIs that don't speak GeoJSON or GeoService. So the provider is what will translate them into GeoService and then from there into feature services. And so we can pull up the demo, which I think is the next tab over. So here we have just a web map, and this is a city of DC. And so, we're pulling in open data, so things like parks, things like grocery store locations, metro entrances, and we're pulling in data from Yelp. So these little restaurant icons here is all from Yelp, and these little, it's kind of, maybe I should zoom in a bit. These little listings, like 2-bedroom for $2,700, et cetera, that's all pulled in from Craigslist. And then now that we're in the web mapping context, we can actually use all of the geo-enrichment capabilities from ArcGIS Online. So these little shaded areas are 5-minute walk time analysis, basically, from a grocery store. So if you're looking for a place to rent and you say, I want to live somewhere within a 10-minute walk of a grocery store, you can sort of use the tools that ArcGIS provides for you with this third-party information. So it's pretty powerful, and again, there's sort of a limitless number of applications because there's so many APIs out there that can be brought into the ArcGIS ecosystem using Coop.
I interrupt?
Yeah, of course.
I should point out, correct me if I'm wrong, but Coop, if you want to use Coop, there's no public instance of Coop in Esri's infrastructure. If you want to use Coop, what you'd do is you'd bring it down from GitHub and get it running on your own infrastructure or maybe up in the Amazon cloud. Yeah?
Yeah.
Okay.
And there's a, I don't know where the talk or the link to any slides are, but there was another talk on Coop about launching a Coop cluster using Kubernetes, which is a way of launching sort of scalable apps. So you basically have these containers and you tell Kubernetes, I want 1 instance or 5 or 10 or however many. And it's sort of it's easy to deploy because all you need is a configuration file, which can be written in YAML, and the docs are pretty clear on how to do that. So that's another option. Instead of going bare metal or AWS, you could possibly use something like Kubernetes. So moving on to DCAT. DCAT is a metadata specification for describing data catalogs. It's a W3 spec. It's been out there for a while. And it's sort of another way that ArcGIS Open Data achieves interoperability. So for example, the LA GeoHub has their own DCAT catalog, and they get it essentially for free. If you create an open data website, we will reserve the data.json URL for generating a DCAT catalog. And what that allows your organization to do is to federate your data up to a portal such as data.gov, which is sort of a nationwide open data portal. So that would allow a researcher who knows about data.gov but maybe doesn't know about any particular open data website to search there, and they will find your data that way. And now, if we want to talk about the actual Open Data API, we'll talk about a few things that it's not. So it's not the portal API. So it's a different backend. It's a different specification. It's not the GeoServices API either. So it's again, it's used primarily for surfacing open data datasets and also for managing open data sites and sort of other open data administrative tasks. So a simple API example. This is our domain. We have a namespace /API/v2. You have a resource that you're interested in, so in this case, data sets. And then you have a optional set of query parameters. So in this case, someone's querying for crime data sets, and they want the third page, and they want each page to have 5 results. So the full URL would look something like that. So a quick aside on the V1, because I went straight to V2. What happened to V1? Basically, don't use it. It's no longer really supported, and we have a few sites that are still running on it, but we're shifting everything to V2 because it's basically better in every way imaginable. Would you agree? Yeah. So don't even bother with V1. So what uses the Open Data API? So our sort of umbrella website, which is at opendata.arcgis.com, which is written in Ember, that works against the Open Data API. Any custom sites using the Ember framework, so the release that we, starting probably last fall, any sites created around then or later, they are using the V2 API. And the admin app is also using the V2 API. So one thing it does is it versions using via the URL. So you saw the API/v2 that tells us that you're requesting something from the V2 API. It returns JSON, and it's the only format that it returns anything in. And it adheres to a standard, which is called JSON API, which is not the most creative name for a standard, but it's all caps, so that's how we know we're talking about the standard versus a generic JSON API. And JSON API defines some patterns. So the top example here, API/v2/some given resource. So if I'm interested in data sets would go there. If I want sites would go there. If I have the ID for a particular resource, then after the resource, slash whatever the ID is, and you will get back just that resource. And then we have the ability to query for related resources. So let's say you had the ID for a site. So you would have a URL, site / the site ID / datasets. So the request you're making there is you want the datasets that belong to that site. So why use JSON API? One thing that it does is it standardizes JSON responses. So you don't have to know how each individual resource looks or how certain endpoints behave. You can expect sort of fairly predictable behavior based on the responses. Supports other features. One feature is called sideloading, which sort of a brief description. It allows you to request resources that are related to whatever you're trying to get. So I'll do an example later, but you could do a request like, give me all of the data sets about public schools and the organizations that own those data sets, and you can get back all that information in one single request. It also supports client-defined payloads. So if you're creating an application and you only need a subset of the full payload, you can actually tell the API, I don't want the full document because that's going to blow up the payload size and make my app slow. I only need these 3 fields from a data set or whatever resource you're trying to request. So it allows the client to optimize by requesting a subset of the full payload. Because it's a standard, it has a lot of client and server implementations, so you can use work that's already ongoing in the open source community. Those can be found at jasonapi.org/implementations, and there are implementations for both clients and servers. Because it's a standard that mediates between clients and servers, there's implementations for both sides. And if you want the actual format for the entire specification, the same website /format. And so we're going to go a little more in depth into the actual querying abilities. Full text queries are supported using the queue parameter. And so this is an example of a request for parcels, pretty straightforward. You can sideload resources, and you use the include parameter in order to do so. So say I wanted to ask, or say I wanted to make the request, bring me all the data sets that match the query parcel, and also include the organizations that publish those data sets. That URL looks like this. So it's a sort of an information rich and dense request, and you don't have to, in many APIs, you might have to make the first request and then have an array of subsequent requests that you have to generate based on that. JSON API is very good at reducing the number of requests you have to make. So we're going to briefly talk about the response format. Again, the standardization of the response format makes developing against the API much nicer. So for any collection of resources, JSON API reserves a top-level key called data, and that data key will point to an array. JSON API reserves the same data key for any one resource, and that'll point to an object. So you can basically know to expect one or many things based on the data type that data points to. It also standardizes the object format, so each resource has a similar format. And that looks something like this. So every JSON API resource document will have an ID, which is some unique identifier, a type, so it'll tell you what the thing is, a data set, a post, a comment, a blog, whatever. And then it reserves this key called attributes, and that underneath attributes, there will be the actual information that you're probably interested in, things like the name, the URL, the record count, if we're talking about a data set. If we're talking about something like a blog, it'll be maybe the author, the body of the blog, the tags. That'll all live in the attributes key. So if you request something and you want to sideload related resources, those will come in a key called included, and included will be an array of all the things that are related to the objects that are in the data key. So one really neat thing is that you can include multiple things that are not related to each other, and so the included key will contain a heterogeneous collection of objects. So you might be requesting a blog, and you also want to include the author and the comments. The author and the comments would all live in the same included key. Particular to our API, we include a lot of metadata on every request. For example, under the meta key, we will return the API root and the resource root. We will also return an object that contains the query parameters that you sent over, as well as some statistics that will go over counts of records that match your query and other aggregations. So an example here, this is a query for population. I'm filtering by saying I want only spatial data sets, so things that have extents basically, and I want the page size to be 25 results. It's not, the screen is a little small here, but the meta key actually has a lot of information. It sent you back the query parameters, but it also sent you back the statistics. So it says, on this request, there are 25 hits. The total number of hits that match the query are 186. And it aggregates by certain types, so by content, by tags. So in this case, 101 documents have a tag of census, 97 have a tag of population, 71 match demographics, and you can even get the source. So these are the organizations that publish the data set. So in this case, US Federal Maps and Apps and Miami-Dade County show up in that aggregation. And this can be useful for things like generating a faceting sidebar or just helpful in general for when you're making queries to the API. So pagination is also another thing that JSON API defines, but kind of leaves some wiggle room for particular implementations. The way we've decided to do that is to actually populate this links key and to give you the first, the last, and the next page. And what this allows any client to do is to make the first request and then to get the next page of the request, not by building the page in some JavaScript code and then launching the next request. You can literally just go to links, go to next, and then that gives you the URL for the next page. And you can keep doing that until you're at the end. So paging over resources is now a lot easier than having to sort of manually build the next page after every request. Another thing that we've done is we've standardized errors. So if I send over a nonsensical query parameter, the API will actually complain and tell you what went wrong. In this case, it's an unrecognized parameter. And it'll actually reprimand you by saying, like, foo is not a recognized parameter, like, try again. And it'll also try to provide information to help you get better, basically, at making these requests. So sometimes it'll say, hey, these are the filters that are allowed, or it's very picky, which is a good thing, because you want to get that feedback early on. If you have multiple query parameters that don't make sense, foo equals bar and filter for pizza equals anchovies, it'll process all the errors before returning a response. So in this case, it actually returned 2 errors. So you actually, you don't end up in the situation where you're building out a request and you've made maybe 3 errors in it, and you resolve one, and then you get another error message and you resolve another one. This actually tells you up front, here are all the things that went wrong, and it'll try to guide you in the right direction. And we have sort of an unofficial API sandbox. It's hanging off of my GitHub repo, actually. I can show you real quick. There's a nice little warning tab under construction. But if I want to test out some dataset resources, there are the routes that are described here. And here you can actually type in some example. So census, I want 20. Then you hit this little try it out button. This is kind of cool. It'll give you the curl for the command, the actual request URL, and then the response body and the response code. So this is a way to kind of poke at the API, learn about it. Again, it's not feature complete, and there are some things about it that are not complete. For example, the model schema is not very helpful yet, but still useful. And that's, I think, the end of my portion. I'm going to hand it back to Mike.
So I realized while Alex was talking that we've been throwing around at least one term without defining it. JSON. Probably you all know what that means, but I'll just say so. I'll just tell you what it means just in case anybody doesn't. JSON is an interchange format that is basically a subset of JavaScript. You can think of it as JavaScript objects serialized to strings and sent down the wire. And what's awesome about that is browsers speak JavaScript, so they speak JSON. It works really well for browsers. AJAX, asynchronous JavaScript and XML. We're still doing AJAX, but we're not using XML anymore. We're using JSON instead. So at the outset, I mentioned a scenario where maybe you've got a website and you just want to stick a little open data search widget on it to search your open data on your existing website. I built an open data search web component that does that. That I'll show you here in a second. A web component it basically leverages a collection of emerging W3C web standards to give you what amounts to a custom HTML element. I don't really know what the status of those standards is at the moment. There was some question about how seriously Firefox was taking some of them, but I'm pretty sure this works in all major browsers now. So this is what it looks like. I've got 2 instances of it on this demo page. Top one here we've got styled nicely with Bootstrap. If you type a search string, you get search results. And then of course you can click on one of them and it'll take you to our umbrella open data sites dataset page for that dataset. Down here we've got, so the idea when I built this was try to make the simple case as simple as possible, but make more complicated usages possible. So down here we've got a slightly more complex usage where we have customized the way each search result displays by giving it a thumbnail and a download link. You click the download link and it downloads. These also we customized because we link into Washington DC's open data site. The way this would, the way you'd use this, actually so this is the GitHub repository. The way you'd use this is you could npm install it into your app, or just the built JavaScript is up here in the dist directory too. You could just download it. And then you need to drop a script tag on your page, and then you can use that script tag defines this custom HTML element, and then you can just drop that element on the page where you want to use it. And just like, built-in HTML elements, you customize its behavior by, declaring attributes. One gotcha is, since the JavaScript defines the HTML element, you have to put JavaScript in the page before you use the element. So that probably means putting it in the head. I'm sure you've all been advised, don't put your JavaScript in the head. That's one piece of JavaScript you're probably going to want to put in the head if you want to use that. So that's that. Alex talked a bit about the Open Data API. From his perspective as the guy who built it, I'm going to spend a bit of time now talking about it from my perspective as one of the guys who consumes it every day. And the first thing I'd say about it is that it's probably the most, or at least one of the most developer-friendly APIs I've ever used. It's really convenient to use in a lot of ways. But what can you do with it? Well, you can build an app. ArcGIS Open Data is built against the Open Data API, as well as all of our customer sites as well. And just to be clear, what we're talking about is a static website. Your web server serves JavaScript, HTML, and CSS. It lands in the browser. Your app lights up and then starts talking to the Open Data API. That's the style of app I'm talking about and what I'm going to demo here. At a very high level, it's something like this. Get some JSON and stuff it into the DOM. This isn't how we really do things anymore, but at a high level, that's sort of what's going on. The way we do things these days is use a front-end JavaScript MVC framework, like one of these. Open Data, the current iteration of Open Data is built in Ember, which is really awesome. I recommend it. Previous versions were built in Backbone and Marionette. Really, you probably couldn't go wrong with any of these. I've got a demo to show you, 2 demos to show you, one in Backbone and one in Ember. But first, just a little bit more about the API from my perspective as a consumer. If you were to build your own Open Data app, it's probably going to involve searching for data sets, looking at details about a data set, and maybe downloading data sets. So your key endpoints that you'd be interested in, Alex I think showed you this one. API, I want to go out of full screen. How do I go to full screen, Alex? You made me go to full screen and I don't know how to get out of it now.
Control-Shift-B, or Command-Shift-B.
Ha, that's funny. There it is. We're still sort of in full screen, but anyway, I want to see the URL bar, which is not that legible for you. But So, oh, and now we lost it. Darn. Dave, do you know how to get out of full screen? Oh, here we go. Now I can just use view. There we go. Okay. So actually, first thing to notice that I want to point out is this isn't what the response from the API really looks like. I'm using a nifty little, the response really looks something like that, right? Not very useful for if you're trying to just poke at the API in the browser to try to understand it and explore it and maybe debug why it's not giving you the responses you're looking for. So this is called JSON Formatter. It's a Chrome extension, and if you're working with JSON APIs, I recommend it. Another good app that used to be a Chrome extension, but now is sort of a standalone app, is Postman. But there's a whole ton of cool things about this API. At a high level, we always have a data key. We always have a data key, and in this case, when we're searching, it's an array of what we search for, data sets. We get an ID, a type, and then our attributes, which is the goodies that we're asking for. There are some cool things about this that you can do. One is you can say, I'm not interested in all this junk, and I want to keep my payload small, so you can do something like, I'm adding, I don't know how well you can read that, so I'm just going to tell you what I'm typing. I'm going to say and fields, bracket, data sets, equals, just title. Or you could say title, comma, whatever, quality, which is actually another cool thing. So, and what we got back was we got just those two attributes, not that whole big payload that we're maybe not interested in. So that's pretty neat. Some other cool things about this, Alex talked about the errors. I want to show you a little bit more about those because it's kind of awesome. If I do something dumb like say fields foo, oops, wrong tab, and low res. What I got was a 400. A 400, that's right, it's a bad request. And that's awesome. It not only did it give me an appropriate HTTP status code, it also in the body told me what I did wrong. That's really awesome. And this is what I'm talking about when I say that this is a really developer-friendly API. It guides you towards doing the right thing. So another key endpoint would be, so that was search. Actually, another thing I want to show you about search that is useful is if you want to scope it to there we go. If you want to scope it to just give me the open data in a particular open data site, you can do. Don't tell me, Alex. Here we go. Filter catalogs. We have. Oh, yep. Thank you. You can do filter catalogs. Catalogs equals that. Yeah. And now, it might not be obvious. Well, it is kind of obvious. This is only data from that site. So that's another useful thing. So if you are, so that's search, but then you might want to show dataset details. So that's, WAC API, v2, WAC datasets, ID. And I actually noticed that this morning, but I left it so I could show you a little more about errors, which is fun. So if I refresh it this time, we got another appropriate HTTP status code, a 404, because that resource, that data set's not there anymore. So we got a 404. That's the appropriate HTTP status code, which is nice. It makes it nice when you're just sort of poking at it to understand it in a browser like this, but it also makes it easy to handle errors in your code. And then, if I'm exploring an API like this, I might say, well, darn, I need an ID. So let's just go back up a level to the data sets and get an ID. And now we can stab that onto the end and see what that response looks like. And we see that our data key is an object this time, not an array. So that's handy. And then, of course, on that we could also do the neat little thing where we just said fields, data sets equals just what I want, like title, maybe just title. Probably not just title, but you could. And then a couple of other key endpoints that you might want to use are this related endpoint. Oh, right. Well, yeah, I'll show you that first. The related endpoint, and again, I think I still have that ID on. There we go. So the related endpoint also gives you an array. It gives you an array of data sets that we believe are related to the data set you asked for. And I just remembered that I wanted to call out this other thing that's kind of nice, and you can also filter by, which is quality. It's a measure of how good we think this data set is. So that's kind of cool. And another key endpoint that you might want to use is this autocomplete one. This one we don't have namespaced under API v2, but it can't go away because I need it. It's for autocomplete. We pass it a query, and it returns an array of strings which are search suggestions that are going to, if you do a search with any of those strings, you're going to get results. And we use this in Open Data. We use this in Open Data for our, oops, no, no. Oh, it's just really low res. Okay. We use this in Open Data to power our autocomplete, of course. So if I do a search, you'll see two things. You'll see down here, you'll see requests that hit the autocomplete endpoint, and then up here you'll see the strings that we got back from those requests in the UI as suggestions. So that's how we use that and how you might. A couple other key endpoints are if you want download, WAC datasets, WAC ID, .csv, GeoJSON, KML, zip for shape files. So you can do downloads that way. Errors, we've talked about errors. Alex did. I've showed you a little bit about errors. The way it handles errors is really cool and useful, and I already showed you that it's nice if you're just poking at it in the browser that it tells you what you did wrong, but when you're right, I mentioned a minute ago that it makes it easier to handle the errors in your code, and this is why. If you've used like our GeoServices endpoint, querying feature services or map services, you've probably experienced the situation where you got a 200, yay, except there's an error in the JSON. That's not the way it's really supposed to work. If there's an error, you're not supposed to get a 200. 200 means success. So when you're using those endpoints, you need to do stuff like this. Check for an error in your success callback, and then also handle errors in your fail callback. You don't have to do this part with the Open Data API. If you get a 200, it means you've been given what you were asked for. You just do something like this, where you can check the HTTP status code that you got back because you can trust it. And then handle 404s maybe differently than you handle 400 or 500 or whatever. A couple of gotchas. This is not really a gotcha. This is a good thing, but it's something you need to be aware of. It's SSL only still, right? Yeah. And that's the way it's going to be. I would imagine, right?
Yep.
Yeah. No JSON-P support, but it does support cores. That's still true, right?
Yes.
Both. Cores though, with cores, I should define my terms again. Cross-origin resource sharing. Browsers enforce same origin policy. You can't, if your page is loaded at, myopendatasite.com, browsers by default don't want you making requests to arcgis.com. Cores allows you to do that pretty seamlessly under certain circumstances that you don't even really need to know about that rule in a lot of cases. But IE10, browsers will just basically do it for you. But IE10, below IE10, that's difficult and possibly impossible. So a couple of demo sites, and yeah, you're not missing much with that text that's cut off because of the really crazy low res we have here. That's just a link to the GitHub repository, which I think share at the end of the deck. Actually, we can go back to full screen. Let's go back to full screen. There we go. And we still can't see it. Anyway, it's just a link to the GitHub repo. It's Esri DC /opendata-backbone. Nope, that won't really work very well because reveal. Anyway, this is an wow, crazy low res. This is just a demo site, a demo open data site that does the very basics that I've talked about: search for data sets, show details on data sets, download data sets. I've written it in Backbone, so I'll show a little demo that won't be quite as cool as it could be. Because, oh no, okay, this will work okay. So we'll just search for nothing, and we got nothing, which is kind of strange because it's a demo. There we go. Okay, water does yield something. So you can search, you get paginated results, and you can click on a data set to get details. And then, of course, from the details page, you can download spreadsheet, KML, or shapefile. Let's download a shapefile. There it comes. So pretty simple. Leverages, of course, what we've been talking about, the Open Data API. And so it's built with Backbone, as I mentioned. At the time that I built this, I was writing a lot of Backbone, so it was easy to whip this out real quick. I'm not writing any Backbone anymore, but this is still a good demo. If you're a Backbone person, or maybe a person unfamiliar with JavaScript front-end frameworks, it might be worth looking at this one. So how would you use this? Well, you could just dig into the code and just look at it to try to understand what's going on, and maybe just use it to glean ideas, or you could fork it on GitHub, and then you'd clone it down onto your machine and run a few commands, just a couple of commands, and in a couple of minutes you could have this running on your machine, and then use that as, well, from there you could customize it and extend it to meet your needs. So there's a lot of code going on in there, but the data access code is really kind of the important part, and that's pretty easy. Backbone has the notion of a collection that knows how to talk to JSON endpoints. It doesn't speak JSON API, but all you really have to do to get it to talk to the Open Data API is tell it how to construct URLs. That's what's going on right there. And then basically tell it how to speak JSON API, which is what's going on there at the bottom. Pretty simple. And then you can use that dataset collection that I just showed you, part of anyway, and just new it, and then call fetch on it, passing it search parameters, and now you've got data sets. Extremely similar thing going on with Backbone's model. So collection, of course, is a group of things. Model is one thing, but they work very similarly. Override URL to tell it how to construct URLs, override parse to tell it how to handle the response, and new it, and then call fetch with an ID. And that's how, and then it would ask the Open Data API for that data set. So that's Open Data Backbone. more recently, but still kind of a while ago, I made the same app in Ember. We're now using Ember for basically all of our development. And Ember is really awesome. I've been really happy with it. It's a very opinionated framework, which years ago when I first heard people saying things like that, I found it maybe a little off-putting, but that's actually, if you can live with Ember's opinions, it's awesome. And you can probably live with Ember's opinions because the guys who build it really know what they're doing, and they have built real ambitious web applications, and so the opinions that they have imposed on Ember make sense for well, many use cases. So it looks and behaves exactly the same, so I won't demo it again. I'll just show you a little bit of code. It's built with Ember, of course, and both use Bootstrap for styling and layout. Again, you could fork this on GitHub, run a few commands. You'd want to install Ember CLI. It's not impossible to build Ember apps without the CLI, but I wouldn't recommend it. It gives you, you can scaffold. It gives you lots of tools to make building Ember apps easier. You can scaffold an application. You can scaffold the bits of an existing application. You can run your tests. You can do your build, do your deployment. That's what Ember CLI gives you. So you'd want to install that globally with npm, then clone it, install your dependencies, and run Ember serve. And now it's running on your machine, and you could extend it, customize it for your needs. And the data access stuff is to get Ember to talk to the Open Data API is conceptually at least similar to what we did in Backbone. Ember Data is a data abstraction for Ember. And so this is basically, in Ember Data, you override functions as necessary in an adapter to tell it how to talk to your API, or how to construct URLs, really. And a serializer, which basically tells it how to pack up its payload to send it up to the API, or how to handle the payload it gets back from the API. So similar to what we saw with Backbone. This is a little more verbose, which is kind of funny because Ember tends to be less verbose than Backbone. Also, I wrote this a long time ago. This might not all be necessary. This is the serializer part, but really don't use that. Because we now actually, our team has been using Ember for, I'm not actually sure how long now, maybe a year, maybe more. And we have we've extracted a lot of the reusable code from our projects into add-ons, which are one of the great things about Ember is there's a thriving add-on ecosystem. So you can install Ember add-ons to do basically anything you could imagine. And in this case, we have an Ember add-on called Ember ArcGIS Open Data Services, which wraps up the Ember data stuff that knows how to talk to Open Data API. So instead of writing this code, which I told you works but is probably suboptimal, you could just do this, and then once you've done that, you have access in Ember's routes and controllers to a store, which is basically, that amounts to Ember Data. It's how you interact with Ember Data. So you can just say, if you want to search the Open Data API, you would just say this.store.query datasets, tell it you want to search for datasets, and then give it search parameters. And then similarly, to get one dataset record, you just do this.store.findRecord of type dataset and give it an ID. And these are just incomplete snippets, but I've done this where you do this probably is in a datasets route. Ember, as I said, is very opinionated, and so with your Ember objects, you've got lifecycle hooks that are well thought out, and they allow you to customize the behavior of your different Ember bits as you need. And one of the most common lifecycle hooks on the route is the model. That's how you override that to fetch your data, and then that becomes the model for that route. So that's what's going on here. These are kind of fun to build, and I wouldn't mind building another one, but the truth is I'm pretty busy. But if anybody has a burning desire to see another sample in perhaps one of those frameworks, I'm kind of interested in those frameworks. If you bother me about that, I might be able to carve out some time, or more accurately, get my boss to let me carve out some time. So that's about it. We can take questions, but this last slide is just some resources at the top. This one, of course, is the presentation. Coop, JSONAPI.org. Alex's, this is the Sandbox, is that right? Yeah. That Sandbox that he showed you. And then, of course, emberjs.com and backbonejs.org.